Hello everyone. This video is on Core Java Chapter 4. In this video, we are going to discuss different type of data types in Java. Now in Java, the data type, they are known as either the primitive data type or simple data types. As you know that Java is statically typed language. What that means is basically that in Java, before we use any variable, we need to first declare it. Now, how to declare that variable is? First, the variable type, that whether this one is an integer type or character, or it's a boolean, or it's a float type, and then its name. And after that, if you want to assign any value, you can assign that value. For example, over here, one variable current is defined and the type is int, basically integer type, and then one value is assigned to it, and then there is a semicolon which suggests end of that particular statement. Now, primitive data type, they represent single value instead of object. And the reason why primitive data types are kept as simple data types in Java is that if they will be also defined as objects, it will degrade the performance too much. That was the reason when Java was developed, these data types, primitive data types, they were kept as simple data types instead of objects. Now, all these primitive data types, they have a specific range and they have some specific mathematical behavior. What's that mean is we will see actually in next couple of slides. Now, let us move to this slide. Now, primitive types or simple data types, there are 8 different types of them: byte, short, int, long, character, float, double, and boolean. All these 8 different types of data, we can put them basically in 4 groups. First one is integer. Integer has 4 types of data. One is byte, short, int, and long. Now, these integer type, they are whole values. So there is no decimal. They are not real numbers. There is no fraction basically. These are whole valued numbers and they are signed numbers. What's that mean is they are going to be either positive or they are either going to be negative. By default, whenever you look at any number, and it is going to be basically integer data type. Next one is floating point. Floating point are 2 types. First one is float, second one is double. These are the numbers now with a fraction. For example, 3.9, 15.12, minus 9.3. These are again signed numbers also. By default, any floating point number is going to be a double number. Now, why that matters, you will see in next couple of examples that whenever we assign some variable and if we don't give basically the type of it, by default it will be considered as double or int, depending upon from which group it is coming from. Next one is character. It represents a symbol from a character set, like any letter or any number in single quotes. Example is over here, is in single quotes, so that is our character type defined as CHAR character, or you see small d again in single quotes. So that's how you define basically a character type. Then the next one is Boolean data type. Boolean data type represents either true or a false value. How you will define it? Boolean B is equal to false. So what we are saying over here is that B is a Boolean type, and once B is a Boolean type, then it can store only either false or a true value. Now let us go in detail regarding integers. As we discussed before, integers, they are signed numbers. Signed means positive and negative values it will be able to store. And integers are 4 types. First one is byte, short, int, and long. Now the first one, byte, as the name suggests, 1 byte is equal to 8 bits. Now this byte type, it is the smallest integer type. It is signed 8-bit. Remember, as I said, 1 byte is equal to 8 bits. So byte is basically a signed 8-bit type. And the range is from -128 to 127. Now you may wonder why 127, why not 128? Remember that there is a 0 also, so we need to count that one also. So the range is -128 to 127. How you will define it? Simply byte distance is equal to 15 and semicolon. Now let us try and find out what is the difference whenever we type byte is equal to 127, which is basically the max range on the positive side. And then what will happen if we try to give byte is equal to 128? Now, before we try this, just one quick note over here. Byte data types, they are very useful to save memory, especially whenever we are working with large arrays. And we will see in next couple of videos that what's actually that mean. Once we will use them, then you will know that practically where basically we can use byte. Now, let us type basically one program. And I hope you remember that this was one of the examples. So I will just simply, so now remove this one. This one was our program from chapter 3. So let me run it once again. Simply, we are printing this message, welcome to Java. Now, we just discussed byte. So let me define byte. So I will say byte B is equal to 15. Okay, now let me print this one. System dot out dot println, and I will define B, and we are all set here. Now let me print this one. Let me run this one. Okay, so we define one variable byte type, and I assigned one value 15, and now I'm just simply printing it. And here is the value. Now let me define another variable. I will say byte C is equal to the max range 127. And now I will print this one also. So I will say system dot out dot println, and I'm typing C, and all set. Now let me run this one. So no issue whenever we are trying to print the max number on the positive side. Here we assign that number to variable C, which is type byte. Now if I will go beyond range 128, now you will see that ID is complaining about something, and it says type mismatch, cannot convert from int to byte. Now I hope you remember that we said that by default any number from integer family, whenever it's not defined, system will basically consider that as a int type. So what happened over here is that as soon as we went over limit, the max limit for byte, now the next number is 128. So compiler started complaining that 128 is int type and you cannot store int type into byte. Now byte takes only 1 byte or 8 bits. Int is bigger. Int takes 4 byte, 32 bits. So you cannot store a bigger number into a smaller number. Now what's the solution for that? What we can do is another interesting thing. I will say that consider this basically this number as byte. So what I'm doing over here is I am casting basically this number 128, and now what I'm saying is that consider this number 128 as byte and store that over here. Now the most important thing what we need to notice over here is that we know that the range of byte is only up to 127. How we can store 128 over here? So let me run this and you will see the result, what will happen. Minus 128. Very interesting. And why that happened is, we will discuss later on in future videos that why this happens, but just to give you a quick note over here. So 127, if I convert that into binary number, it will be 0, 1, 1, 1, 1, 1, 1, 1. Now this last digit, this is used for sign. So when it's 0, it means it's a positive number, and whenever it's 1, that means it's a negative number. So if I add 1 bit over here, what will happen is that number will be minus 128. And why that will be? Because if you add that, now this will be 1 0 0 0 0 0 0 0. I hope you know how to add a bit over here. And now this last digit is basically 1. And if you will convert this into decimal again, it will give you minus 128. This bit basically is telling us in this scenario that it's a negative number. Now let's go back to our PPT. Next one is, we tried already this example, so this is just for you. Please type it and try different things, do different experiments, play around with the code. As I said before, the more you will type, the more you will play around, you will learn more and more new things basically. Now, the next one is show type. Short type is 16-bit type. That means it is 2 byte. It can store the signed 2 byte basically. And the range is minus 32,768 to 32,767. And short is basically the least used Java type. Not too many programmers are using short when they are doing the programming in Java. And how to define it? You can see example here, short km is equal to 15,000, short day is equal to minus 5,000. Remember that this is short is again signed 16-bit type. So it can store into 16 bits, 2 byte. Next one is int type, signed 32-bit type, 4 byte basically. And the range is, you can see it has a long range. If you can remember, great. If you can't, that's fine. Int is most commonly used integer type. Whenever programmers do development, int is most commonly used. And how to define it? Simply, int s is equal to 15. And what we are saying here is that s is of integer type and the value is 15. In integers, the last one is long. As the name suggests, it can store 64-bit type of data. So basically 8 byte of data. And how you will define it? Long t and then the value. Long is primarily used when there is a need to store a very big number. At that time, we use long. The number which we know that it will be out of range for int to store, at that time we will use long. Now the next type is floating point. Floating points, as we discussed, floating point numbers are basically number with a fraction value. These are the real numbers also. We call them as real numbers also. Now, there are two types. First one is float and second one is double. Now, if we look at float, it is a 4 byte or 32 bits, and float specifies a single precision value. So 32 bits, single precision. And how to declare them? Either float height or float height is equal to 15.6. Now, over here, there is a comment. It says something wrong here. Can you guess what is wrong here? If not, let us type this one in our IDE and try. I will type after this one. So I will say float height is equal to 15.6. Now IDE is complaining. Let us see what it says. It says type mismatch, cannot convert from double to float. So I hope you remember that by default from this family, any value with a decimal is a double value. And what we are trying to do is we are trying to store a bigger number into a smaller type, which is basically float. We are trying to store a double number into Boolean. That's why it's complaining. And how we can do that? Like the last time we did that, I can do the casting, and here we go. No issue now. So we are saying 15.6 is a float value, store it basically in height. Let's go back to our PPT. Now, next one is double type. Double specifies double precision value. Remember that float was single precision, it was 32 bits. Now, double is 64 bits, so it's double precision. How you will define? Like the way we defined float. Now instead of float, we will say double. Temp double height equal to 15.6. So we are saying here height is of type double and it has value 15.6 assigned to it. Next one is character types. This data type used to store basically characters, and it is 16 bits or 2 byte, and the range is 0 to 65,536. There are no negative characters, and it can also be used as an integer type on which you can perform arithmetic operations. Now this is very interesting, and we will see what's that statement mean actually. Let us type one small program here. So I will type it here. So I will say character x is equal to, I will define a. Here we go. A. And CHR not. Okay. Now let me try to print this one. System.out.println and typing x. We are all good here. Here we go. And now I will run this program. Now we defined one variable x, which is character type, and the value we assigned is a. And simply we are printing that value over here, a. Okay. Now how it perform arithmetic operations? So let us try that. I will try to do something over here. So if I try plus 1, can you guess what will be the result? Okay, let us see. Let me execute this one. Now 97, 98. Now the value of a in ASCII character set is 97. So what it did is 97 plus we are doing because this is an arithmetic operator. So it converted that value of a over here. So it bring it over here, which is 97, and then it added plus 1 and it printed over here. So that's what it means when it says it can also be used as an integer type on which you can perform arithmetic operations. In next videos, couple of videos, we will see whenever we will write programs more detail that how basically it works. Now let us move to the next slide. Boolean types. Boolean types are used basically to store logical values. Logical values mean either true or false. How to define them? I defined over here Boolean A is equal to false or Boolean A is equal to true. Only two values. In Boolean type, only two values will be there, either true or either false. Now remember that there are default values for these data types. By default, byte default value is 0 for short, for int, for long, float. And if you want to try this one, you can type this program and let us run it. I will simply type this program. Here we go. Now, one thing you need to note over here is that all these variables which I defined, they are static type. We will discuss in detail what's that mean actually and why I define them actually outside of our main. They are not defined over here in the main method. They are outside of main. And now if for timing, let us run it. And here by default, the value of, I didn't define true or false. What I'm doing is I simply defined it and then I'm simply printing it. So by default, it says false, 0, character blank, there's nothing, null, 0.0 float. So this is the default value set. Let's go back to our PPT. Now in the next chapter, what we are going to discuss is white space, identifiers, literals, comments. There are 3 different ways to create comments, 3 different types of comments you can say. We will discuss them. Then we will discuss about separators. We will discuss what are Java keywords. And then we will discuss about Java class libraries. So this was pretty much for chapter 4. Very important, very good information. And we are going to use all this information in all future chapters. So thank you very much. And let us look at chapter 5 now. Thank you.